Can we adapt to the conditions on Mars and walk on the surface of the red planet? Here are 5 steps we could take to make it happen. The first crucial step towards colonizing Mars is mastering space travel. In the realm of interstellar voyages, our current state is akin to a toddler taking their first steps. We've had some stunning achievements, including landing humans on the Moon and sending rovers to Mars. However, these are short trips compared to the marathon of a manned mission to Mars. The challenges of long-duration spaceflight are numerous and significant. The journey to Mars takes around 6 to 9 months, depending on the alignment of Earth and Mars. This is a prolonged period of exposure to microgravity, cosmic radiation, and the psychological strain of isolation. These are not insurmountable obstacles, but they require innovative solutions. The development of reusable rockets is one such innovation. Reusability can dramatically reduce the cost of space travel, making Mars colonization a more feasible endeavor. SpaceX's Falcon 9 and Starship are shining examples of this potential. Advanced propulsion systems are also essential. Conventional rocket engines, while reliable, are relatively slow. Faster propulsion methods, like nuclear or ion propulsion, could significantly shorten the journey to Mars, reducing the risks associated with long-duration spaceflight. In this era of rapid technological advancement, the dream of Mars colonization is not beyond our reach. It requires determination, ingenuity, and a commitment to pushing the boundaries of what is possible. Once we've conquered space travel, the next step is to establish a sustainable life support system on Mars. But what does this mean? Well, imagine being stranded in a desert with no access to food, water, or breathable air. That's Mars, but on a planetary scale. So we'll need a system that can provide these essentials: air, water, food. These are the 3 pillars of our existence, and we'll need to create a system that can provide all 3. Mars does have resources that we can potentially use. For instance, its atmosphere is carbon dioxide rich, which we can convert into oxygen for breathing and even fuel. Ice caps on Mars could serve as a source of water, and as for food, well, we might just have to take a leaf out of Matt Damon's book and start growing potatoes on Martian soil. Harnessing these resources will require advanced technology, some of which we're only just beginning to develop. But remember, this is not just about survival, it's about creating a sustainable life, a new home away from home. A sustainable life support system is the key to our survival on the red planet. With a life support system in place, the next step is building the necessary infrastructure. Now let's think about this. We're not just making a temporary campsite, we're forming a new society on a different planet. This is no small task. Firstly, we need to construct shelters. These won't be your run-of-the-mill buildings. They need to withstand Mars's harsh environment, the thin atmosphere, the extreme cold, the dust storms. We're talking about airtight, insulated structures that can protect us from radiation. Next, communication is key. We need to establish a reliable communication system between Mars and Earth. This will be our lifeline, our link to home. It will allow us to share our findings and receive support when needed. Finally, we'll need facilities for research and development. We're explorers, after all. We'll be studying Mars, its geology, its climate, its potential for life. We'll need labs and equipment to do that. An efficient infrastructure will ensure our long-term presence on Mars. Having built our infrastructure, we must now adapt to Martian conditions. Mars presents a unique set of challenges. Its thin atmosphere, for instance, only contains 1% of Earth's atmospheric pressure, making it hard for humans to breathe. Additionally, the red planet's gravity is just about 1/3 of Earth's, a condition that could lead to muscle atrophy and bone loss over time. Not to mention Mars' extreme temperatures, which can drop as low as -125 degrees Celsius during winter at the poles. Such frigid conditions could prove fatal for human inhabitants. But fear not, for we humans are masters of adaptation. Advanced spacesuits could provide the necessary life support in harsh Martian atmospheres, while genetic engineering might allow us to tweak our biology to better withstand Mars' low gravity. The final step in our journey is growing a self-sustaining colony on Mars. This is where the magic truly happens. It's not just about increasing numbers, but about nurturing a diverse and thriving community. We're talking scientists, engineers, doctors, teachers, artists, a microcosm of Earth's society, but on the red planet. We need to ensure that our Martian society has the capabilities to sustain itself. This means establishing an economy that thrives on Martian resources, a robust education system to foster growth and innovation, and a form of governance that ensures the well-being of all colonists. Imagine a bustling Martian city, factories processing Martian soil into building materials, greenhouses cultivating Martian-grown food, schools teeming with eager young minds ready to solve the next big challenge. This is the future we could create. Growing a self-sustaining colony is the ultimate goal of our mission to Mars. Colonizing Mars in the next 10 years is a monumental task, but not an impossible one. A journey that takes us millions of miles from the comfort of our blue planet into the vast abyss of space. Our survival hinges on our ability to create a bubble of Earth within the inhospitable Martian landscape. The red planet offers a harsh environment, but we are a species known for our resilience. With determination, innovation, and a touch of audacity, we might just become a multi-planetary species within the next decade. Thanks for watching. If you enjoyed this video, please consider sharing it. For more brain-boosting content, hit that like and subscribe button.